OK, so I wanted to start off our discussion of the internet with this video from The Onion. And so this is kind of poking fun at some of the buzzwords that arise around the internet and networking these days. So in particular, a lot of people talk about this thing, the cloud, without really knowing what it means. And so one of the goals over these next 2 weeks is to kind of unwrap what it means, what these buzzwords like cloud mean. When someone says that I'm cloud computing or backing up to the cloud, what that actually means. So here's just a spoof of what it doesn't mean.
Hewlett-Packard is known for their basic, affordable, no-frills computers. But that doesn't mean they can't keep up with the latest technology. In a press release yesterday, HP said, quote, "We are excited to begin offering that cloud thing that everyone is talking about. We definitely have the cloud on our computers, and it is better than anyone else's cloud." Earlier today, I sat down with HP spokesman Gary Klinman, who said the company couldn't wait to show people, quote, how they do their cloud stuff.
We are absolutely thrilled that now people with computers or phones, both, will now be able to back things up to the cloud. And yes, and that's definitely something that people do, and they will be doing it with HP.
HP is making their cloud technology the centerpiece of a major new print and television ad campaign.
HP is the company I've always relied on. So when I decided to get on my computer on the cloud, which is how you do it, naturally HP was the company I chose. HP's cloud is the perfect tool for emails, Facebooks, texting, and CD-ROMs. How does the cloud work? It's so simple and intuitive, I don't need to waste your time explaining it.
Klinman says it isn't surprising they're, quote, up on the cloud, considering they're on the cutting edge of all the latest tech trends. Now, are there any additional features?
Crowdsourcing is something we are having. Crowdsourcing 2.0. We have social sharing. We have 4G, 5G, 6G, really all the Gs. We have app. We have all of it in the computer.
Despite all of their wide array of technology, HP says they're most excited about the cloud. They even let me take a peek at their design laboratory, where HP engineers were trying out some unique development techniques. So, how much capacity will HP's cloud users have access to?
1,000?
We'll be watching to see if HP's cloud push pays off. Make sure to catch the next tech trends when we'll be looking at Body Do, the popular new device that links with your iPhone to post all of your bodily functions right to Facebook.
All right. So now, over these couple weeks now, we're going to start to actually understand what's going on underneath the hood when we talk about things like the cloud. So let's start off with a demo. So what I'm going to do is I'm going to run a command here. It's going to make a request to CNN.com. What it's going to do is it's kind of output what happened along the way when I made that request to CNN.com. So here I've opened up a terminal, and a terminal is simply a different way to launch programs. So here, rather than clicking on an icon on my desktop, I'm actually just going to type something in and hit enter, and it's going to run some program. So much like clicking on the Google Chrome icon will run Chrome, I'm actually just going to type in the name of the program that I want to run, and it's going to run. So I'm actually on a server here. This is a server that I own. It happens to be located in New Jersey because I'm renting it from some other country. And so this is what happens when I make a request from New Jersey to CNN.com. So we're kind of hanging down here. So we can see basically that along the way, we basically made a bunch of little stops. So down here we have these stars, and these are basically because these stops on the way to CNN.com, these computers are kind of choosing not to identify themselves for one reason or another. But we can basically get the gist of what happened. So here, this first line happens to be my computer. So this is where the request started. And then the request to CNN.com, it looks like it didn't go directly to CNN.com. It looks like it hit upwards of 30 other things or so on the way there. So does anyone happen to know what each of these rows is? So this looks like something here. Then I'm hitting something like VLAN, TBR, MMU. Does anyone happen to know what each of these rows represents? Yeah, so it's a location. So what is the actual physical thing at that location? Does anyone happen to know what it's called? Yeah, so these things have IP addresses, and that's what's over here. So this happens to be the IP address of my server that's located in New Jersey. But each of these rows here represents what's called a router. So each router then has this thing called an IP address, which just seems to be some way of uniquely identify it. And so it seems like when I made a request to CNN.com, it didn't go straight to CNN.com. And that probably makes sense, because my laptop in New Jersey isn't directly connected to whatever machine is powering CNN.com. So it kind of needs to make a few stops on the way. So much like if you're taking a long flight across the country or around the world, you don't usually have a direct connection. You might have a few layovers on the way there, some stops over this long connection. So each of these rows is kind of like a layover on the way to CNN.com. So just reading into this a little bit, we can see here, starting on row 5, this identifier for one of these routers has the word Newark. And that makes sense because I said that my server is in New Jersey. So this looks like this router is located in Newark. So if we start to kind of trace where this request is going, it looks like we start in New Jersey, go to the Newark, then suddenly we're in Washington, then we're down here in Atlanta, and we end up kind of somewhere near Atlanta before these routers stop identifying themselves. So there's a good chance that CNN.com is actually hosted somewhere in Georgia. So up here, these things before Atlanta, these are actually very commonly airport abbreviations. So some small airports in Washington or Georgia probably have these abbreviations. And basically, these lines, these connections from my computer to this router that's connected to another router kind of follows the same path that your plane might as you're traveling from here to Georgia. So let's switch back. So what I just did when I typed in traceroute CNN.com is I made a request to something at CNN.com. And this is the same way that if I opened up a web browser and typed CNN.com, I'd still need to make some request to CNN.com. And I'm basically asking CNN.com for some information. The information at CNN.com happens to be today's news, probably. And so what that is means that CNN is serving me some news. So we call this machine powering CNN.com a server. So a server is basically just a computer whose job in life is to serve other computers some information. So in this scenario, when I'm requesting information from the CNN server, I am called the client, because I am asking a server for some information. And so that's some terminology you may have heard before. If I'm on someone has asked you what's your web client, or you're asking for a web server somewhere. So that's where that terminology comes from. So a server is really, the only role of a server is just a fancy computer whose job is to serve up some content. So as we said, on the way, we hit some routers. So my computer happens to be on the Harvard Wi-Fi right now. So the Harvard Wi-Fi is this large network, but it's not directly connected to CNN.com. Right? The only way for that to happen is for a wire to be physically running from here all the way to Georgia, which probably wouldn't make so much sense. So instead, each of these routers is effectively establishing some path along these little layovers that get me from New Jersey or from here all the way to CNN.com. And so this is kind of what the internet is, right? I'm not directly connected to every other machine on the internet, but I'm connected to some routers that are connected to some other routers that will eventually be connected to the server or the other machine that I'm making a request to. So if we come back to this output here, we can also see not only what router it is, we can see a number that uniquely identifies it, and also the time it took me to get there. So we can see that it only took about 20 milliseconds, my request, to travel all the way from New Jersey to Georgia, which is pretty cool. So we're talking about some pretty fast speeds here. So the internet really then is just this large network, where a network is defined as a bunch of connected computers. So when I have two connected computers, that means that they can communicate with each other. So a really simple network might look something like this. So I just have a computer on the left, and maybe there's a wire running from the computer on the left to the computer on the right. And the computer on the right has a wire running from that computer to the one on the left. And so now, because these two computers are somehow physically connected, that means they can start to talk to each other. So this is nice, connecting things like this. But once we start introducing more computers into the equation, things start to get a little messy. So now if we want to have 4 computers, we had to have all these crazy wires connecting them. And so this is still a network. We have these 4 connected computers, but it looks kind of messy because we have all these wires going everywhere. So instead, you might want to utilize a device called a router. So what a router does is it kind of serves as a communication hub for the network. So now I have 4 computers, and rather than upwards of 16 wires, I now have only 4 wires, each one connected from a computer to a router. So now, if the computer all the way on the left wants to communicate with the computer all the way on the right, it's going to send a message to the router and say, I would like to communicate with the computer on the right. The router is going to say, OK, well, I know that you're not connected there, but I'm connected to that computer, so I'm going to forward your request along all the way to the computer on the right. So now we've basically created a very small network where all of these computers can make requests to each other and communicate. So any questions on networks? OK, so we have a small network here, but what this doesn't have yet is an internet connection. Right? These 4 computers can talk to each other, but they still can't really talk to CNN.com, right? If we just have this little isolated bubble in which these are the only connections, unless one of these computers is powering CNN.com, there's no way for me to connect to the internet. So to do that, I'm going to need the help of someone called an Internet Service Provider, or ISP. So you've probably heard of ISPs like Comcast or Verizon. And basically, the ISP serves as a link from your computer or your home network to the big internet, where all of the other networks are connected to. So your home setup might look something like this. So on the left, we have a diagram that's pretty much the diagram we just saw. We have any number of computers connected to some router. So this is kind of the communication hub. So now all of these computers are connected to the router. Now we're going to connect the router to our modem. The modem is the small device that may or may not also be a router, depending on what modem you buy. But in this case, let's just say they're 2 separate things. And the modem was given to you or set up for you by the likes of Comcast or Verizon. And this is what's actually going to connect to some coaxial cable jack inside of your house. And so that'll run down the equivalent of phone lines and actually connect you to the internet. And so that service that's connecting your home network to the larger internet is provided by your ISP. So just having a wireless router at your home is not enough to get you on the internet. It'll start allowing you to communicate with other computers on the same network. But once you introduce the ISP, who gives you a modem you can hook up to your individual computers or a router, then that's what allows you to connect to the internet. So we have a couple terms for the different networks. So this small network at my home, or maybe the network at the company that you work off, might be called a LAN, or a local area network. And so a LAN is basically a small network that creates a network over a small geographic region. Right? So we're talking the size of a house or maybe the size of a building. So very local. So if all of these computers are directly connected on this network, that means they can communicate with each other no problem. So if we start connecting LANs together, we get what's called a WAN, or a wide area network. So if I have a LAN at my house, and that my neighbors also have a LAN, and suddenly we get connected together because we're both subscribing to the same ISP, we now have a WAN. And that's going to start spanning the areas of cities or different metropoli. And so once we start connecting all of those together, we get the internet. And so the internet then is really just a big network of networks. So a LAN is a very small network at my house, and I'm connected to some other LANs, and some of those LANs happen to be the ones powering CNN.com and some other websites. So because I can connect my network to someone else's network who's connected to CNN's network, that means that I can start communicating across networks to get the information that I'm looking for. So this is what we mean when we say the word internet. So originally it was an internetwork, because you're communicating across networks. So does that make sense? That terminology makes sense? Any questions there? OK. So this is what a WAN could look like. So at the bottom here, I have some LAN that's connected to a router. And that router is connected to another router, which happens to be another network. And so now these bottom computers can communicate with these top computers. And if I ran traceroute, for example, on one of these bottom computers to the top one, we'd probably see a row for the first router. Then we see another row for that second router, that other stop. And then we'd finally reach our destination. So let's try running traceroute on another site. So let's actually try, for example, bbc.co.uk. So I'm going to run this. So we see this one's a little bit shorter, but that means we just hit fewer routers along the way. So our first row looks exactly the same, because we're still starting off at this same machine. And so does anyone notice any big differences between any two of these rows? So this third column is the fourth column is the time, remember? So does anyone notice any big differences in the time? Yeah, so between 5 and 6. So here we have this thing here, this TBR, which happens to be an airport, Washington, I think, or somewhere around there. And so now we go from here to this router here, which is identifying itself as BBC and now code.uk. And so we've gone from 1 millisecond to 72 milliseconds there. So in terms of terms of geography, what actually just happened? Yeah, so we just crossed the Atlantic Ocean, right? So that means that there's a wire running somewhere from some router on the East Coast to another router in the UK. And so it's actually going to take some time for us to actually cross the Atlantic Ocean. And so that's where that time delay is actually introduced. So that means that if I'm in the US and I'm making a request to some other server that's on the other side of the world, it is actually going to be slower, which makes sense because our request actually needs to travel that far.